If what's unfolding in the equatorial Pacific right now, a subsurface heat pulse more than twice the size of anything observed at this stage during the 2023 event, trade winds collapsing ahead of schedule, the Niño 3.4 index already crossing into positive territory, got you locked in? Hit subscribe to Orbital View. We track the data the institutional summaries leave out. Drop a comment below. Where are you watching this from? And what's the one impact you're most concerned about? I read every one. 3 threads in this investigation. A freight train of heat moving beneath the Pacific, invisible, 6 degrees above normal at depths of 50 to 150 meters, and picking up speed. The year that freight train last ran at this strength, and what it cost. And the hidden assumption holding together the global food system, the Atlantic hurricane forecast, and the Western fire season. An assumption that a super El Niño doesn't just challenge. It dismantles. Let's get into it.
Something is moving beneath the Pacific Ocean right now, and most people have no idea it's there. It's not at the surface. You won't see it on a standard weather map. The sea surface temperature charts that drive most of the headlines haven't fully caught up to it yet. But the International Research Institute for Climate and Society published its May 2026 Quick Look 4 days ago, and buried inside the technical language of that document is a measurement that stopped me when I first read it. Between approximately 150 degrees west and 80 degrees west, spanning the central and eastern equatorial Pacific, temperatures at depths of 50 to 150 meters have increased substantially, with anomalies locally reaching up to 6 degrees Celsius above normal. 6 degrees. At depth. Across a stretch of ocean roughly the width of the continental United States. Think about what that actually means. The thermocline, the boundary layer that separates the warm surface ocean from the cold deep ocean, normally acts like a lid. Warm water sits above it, cold water below it, and the whole system stays in rough equilibrium. What the IRI is describing is a situation where the warm water isn't sitting above the lid anymore. It has punched through it. It has pooled beneath the surface in a reservoir so vast and so hot that when it rises, and it will rise because that's what warm water does, it will fundamentally reorganize the behavior of the entire Pacific. For context, current subsurface heat content values are more than twice those observed during the same period in mid-May 2023, during the El Niño event that went on to become one of the strongest in recorded history. More than twice, not slightly elevated, not concerning but manageable, more than twice. And 2023 became the event that pushed global mean surface temperatures to 1.58 degrees Celsius above pre-industrial levels. That was an event the WMO described as sitting on the edge of superstatus, but not quite crossing it. What's building now is at least twice as energetically loaded at the same point in the development cycle. The latest oceanic analysis and forecast data confirms that the El Niño is developing faster and stronger than initially projected, with subsurface anomalies now suggesting this event is on a direct trajectory towards Super El Niño status by the second half of the year. Here's what a Super El Niño actually means, stripped of the jargon. Normally, the Pacific trade winds blow from east to west along the equator. They push warm surface water toward Asia, pile it up like a slow-motion tide, and keep cooler water near South America. The Western Pacific sits about half a meter higher than the Eastern Pacific because of those winds. They're the pump that maintains the whole system. When the pump fails, everything that was held in the West gets released. In April, a pair of cyclones straddling the equator caused the wind direction to reverse. This short-lived reversal triggered a downwelling Kelvin wave, a pulse of energy beneath the ocean surface moving eastward along the equator. That's the freight train. An oceanic Kelvin wave is not a surface wave. You can't see it from a ship. It travels at depths of 100 to 250 meters, moving eastward at roughly 2 to 3 meters per second, covering the width of the Pacific in roughly 2 months. It's carrying a thermal payload that dwarfs anything the surface charts are currently showing. And right now, as you're watching this, it's surfacing. A massive subsurface warm pool has developed in the west, at around 100 to 250 meters depth. The Kelvin wave is making its way east, fully eroding the subsurface cold and emerging on the surface as warm anomalies. A direct comparison of subsurface anomalies for mid-May between this year and the last 2 Super El Niño events shows that this year we are well on par with the last 2 super events at this stage of development. And in the western tropical Pacific, currently warmer than during the last 2 super events at this time. Warmer than during the last 2 super events at this stage, with the waves still propagating. As of early April, observations indicate near-average sea surface temperatures in the central and eastern equatorial Pacific, alongside increasing subsurface heat content. Most dynamical and statistical forecast models suggest El Niño conditions will emerge during boreal summer and autumn, with some suggesting El Niño thresholds as early as May through July 2026 and potentially persisting into the end of the year. That's the WMO, the World Meteorological Organization, not a forecasting blog, not a sensationalist weather account. The same institution that carefully avoids the term super in its official communications was, as of April, describing a subsurface heat signal that most of its member models expect to cross threshold by midsummer. For a super El Niño to develop, two systems have to remain in phase. The tropical Pacific upper ocean heat content has to stay elevated, and the atmospheric circulation has to respond in a way that reinforces the oceanic anomaly rather than damping it. The current subsurface signal is favorable. The oceanic piece is not in question. What remains open is whether the atmospheric piece, the trade winds, the southern oscillation, the feedback loops that either amplify or damp an emerging event, continues to cooperate. And right now, the early signs suggest it is cooperating. The equatorial Southern Oscillation Index declined to negative 0.3 during April 2026, further indicating that the atmosphere is starting to respond to the warming Pacific Ocean, a sign that ocean-atmosphere coupling associated with El Niño is becoming established. Negative. The SOI going negative means the pressure gradient between Darwin and Tahiti is shifting, which is exactly what happens when the atmosphere starts to lock in with the warming ocean. It's the signature of a system that's not just building, but beginning to feed itself. The volume and intensity of the subsurface warm water anomalies, or pulses of unusually warm water that are a key part of El Niño physics, are about as large as we've seen in the historical record. I want to be careful here. The atmospheric piece could still disrupt this. Trade winds could strengthen unexpectedly. A competing atmospheric pattern could interfere with the coupling. I'll come back to what would need to happen for this to not become the event the models are currently pointing toward. But the subsurface signal, the freight train, that is not speculative. It is measured, it is documented. It is more than twice as energetically loaded as the same stage of the event that already broke the 1.5-degree barrier. And the atmosphere is already starting to respond. Before we go further, there's a mechanism you need to understand. Because most of the coverage you'll see treats El Niño as a weather story. Wetter winters somewhere, drier conditions somewhere else, some hurricanes suppressed, a bit of extra global heat. That framing is technically accurate and deeply misleading at the same time. El Niño doesn't just change the weather in specific places. It rewires the engine that drives weather everywhere. The engine is the Walker circulation. Think of it as the atmosphere's great conveyor belt, a massive loop of air that rises over the warm western Pacific, flows eastward at altitude, descends over the cooler eastern Pacific, and returns westward along the surface as the trade winds. That loop is powered by the temperature contrast between the warm western pool and the cool eastern ocean. It drives the monsoons. It determines where the jet streams sit. It sets the moisture supply for 3 of the world's 4 largest grain-producing regions. The whole system, the whole planetary circulation, is calibrated to a Pacific that behaves within a certain temperature range. When a super El Niño erupts, the western pool of warm water collapses eastward. The temperature contrast that powers the Walker circulation evaporates. The conveyor belt slows, distorts, and in the most extreme events, partially reverses. And when the conveyor belt changes, everything downstream changes with it. The monsoon over South Asia weakens or fails because the Walker circulation is one of the primary mechanisms that draws moisture inland. The jet stream over North America shifts poleward, driving warm, dry conditions across the Pacific Northwest and British Columbia while funneling atmospheric rivers into California and the southwestern United States. The ITCH, the Intertropical Convergence Zone, where the tropics release most of their heat into the atmosphere, migrates toward the warming eastern Pacific, pulling rainfall patterns with it. Southeast Asia dries out. Parts of Africa experience multi-season drought. The Amazon, already stressed, faces an additional thermal burden that the canopy's evaporative cooling cannot fully absorb. This is not projection. This is the documented record of what strong El Niño events do, every time, through the same mechanism. El Niño has been linked to crop failures, more frequent wildfires and concurrent droughts, increased flood risk, disruptions to fisheries, elevated civil conflict, and increased disease risk in various regions. That list isn't alarming because it's long. It's alarming because every item on it flows from the same source, a single shift in where the Pacific puts its heat. El Niño typically increases global temperatures on top of global warming, which increases the likelihood of extreme weather events. But that framing, El Niño as a temperature adder, undersells the compound mechanism. It's not just that a super El Niño pushes global temperatures up by another few tenths of a degree. It's that those additional tenths sit on top of a baseline that has already been elevated by human-caused warming. The atmosphere is operating with more energy than it was during the last Super El Niño, more moisture available for atmospheric rivers, more heat available for fire weather, more thermal energy available for the subtropical high-pressure systems that drive drought. Following a rare 3-year La Niña from 2020 through 2023, the 2023 to 2024, El Niño contributed to the consecutive years of record-breaking global mean surface temperatures in 2023 and 2024. 3 years of La Niña. What that means is 3 years of heat accumulating in the subsurface Western Pacific, the same reservoir now being discharged eastward by the Kelvin wave. The ocean was, in effect, charging, and it charged for 3 years before the 2023 event, before the event that shattered the 1.5-degree barrier, before the event that was only on the edge of superstatus. What just ended was another La Niña. It was shorter, roughly 1 year, but it followed directly on the heels of the 2023 event and the residual warmth that preceded it. A series of powerful westerly wind bursts are now acting as a release valve, pushing that stored heat eastward. ECMWF forecasts show unusually strong westerly anomalies across the Pacific, a pattern that directly mirrors the triggers of historical Super El Niño events. The Niño 3.4 Index, the standard benchmark against which every ENSO event is classified, officially crossed into positive territory in late March 2026. That's the surface signal beginning to catch up to the surface reality. And the subsurface reality, as of this week, is still running well above any comparable historical precedent at this stage. There's a number embedded in the IRI data that I keep returning to. The ocean heat content anomaly averaged over 0 to 300 meters depth between the dateline and 80 degrees west is markedly elevated, and current values are more than twice those observed during the same period in mid-May 2023. More than twice the loading of the event that already broke the 1.5 threshold, surfacing into an atmosphere that's already warmer than it was during that event. Through the same mechanism, Kelvin wave propagation, trade wind collapse, Walker circulation disruption that has driven every historically significant El Niño on record. But here's where the story takes a turn that most of the current coverage is missing entirely. Because there's a second layer to this, a layer that's not about the physics of El Niño itself, but about the architecture of what it hits when it arrives. And that architecture, the global food system, the fire weather infrastructure of the American West, the Atlantic hurricane forecasting framework, is built on an assumption that nobody has examined carefully enough. The assumption is that these systems are resilient because they are diverse, that when one region fails, another compensates, that the breadbaskets of the world are independent enough that a single climate driver can't tip them all at once. That assumption has a name in the academic literature, and the science says it is wrong. 80% of the world's people depend on 3 crops for the majority of their calories: maize, wheat, rice. Global food stability hinges on production concentrated in a few specific regions. The architecture of that system, the reason it has been able to feed 8 billion people, rests on a principle that agricultural economists call independent failure. The idea is that the breadbaskets of the world are geographically separated enough, climatically distinct enough, that a shock hitting one region doesn't simultaneously hit the others. If the US Corn Belt has a bad year, Brazilian soy can compensate. If the Indian monsoon fails, Australian wheat fills part of the gap. The system is designed around the assumption that failures are local, but El Niño doesn't respect that design, because El Niño doesn't cause local failures, it causes synchronized ones. Interannual modes of climate variability, such as the El Niño Southern Oscillation, the Indian Ocean Dipole, and the North Atlantic Oscillation, have all affected the relative probability of simultaneous yield shocks in pairs of breadbaskets by up to 20 to 40% in both maize and wheat breadbaskets. Think of the global food system as a console of levers, one hand resting on that console. When that hand pushes down, 4 levers move together because they're connected to the same hand. The hand is El Niño. The levers are India, Southeast Asia, Brazil, Southern Africa. They are connected not through policy, not through trade, but through shared atmospheric physics. Through the Walker circulation, the disrupted monsoon, the displaced jet stream, the moisture-starved subtropics. In 1983, a strong El Niño event simultaneously affecting several breadbasket production areas led to a 20% deficit in global maize supplies. 20%. Not in one country, globally, in a single growing season, and that was an event that didn't reach super threshold. The 1982-83 El Niño event saw maize yields in Southern Africa fall by over 70% between 1981 and 1983. Severe droughts in 1983 caused United States maize yields to fall by close to 30%, while global yields dropped by 11%. Southern Africa down 70%. United States down 30%, global yields down 11%, simultaneously, from the same event through the same mechanism. And Deepti Singh, an associate professor at Washington State University, who has spent years studying these compound failure patterns, stated this plainly when comparing the current developing event to historical precedent. Simultaneous multi-year droughts similar to those in the 1870s could happen again. What is different now is that our atmosphere and oceans are substantially warmer than they were in the 1870s, which means the associated extremes could be more extreme. Warmer atmosphere, warmer ocean, more energy available for every mechanism El Niño deploys. Research shows an increasing risk of simultaneous failure of wheat, maize, and soybean crops across breadbaskets. Climate change is projected to further increase both frequency and severity of such events. The global food system was designed for a Pacific that behaves within a certain range. It was not designed for a super El Niño landing on a baseline of human-caused warming that didn't exist during the last comparable event. The buffer, the assumption of independent failure, is being squeezed from both sides simultaneously. And the year that last happened at anything approaching this scale, the year those buffers failed catastrophically, that year has a number. And when I first encountered it in the academic literature, I sat with it for a while. In the summer of 1877, the Pacific Ocean released a heat pulse so vast that it rewired the weather of the entire planet. Monsoons failed over India. Rivers ran dry across China. The Brazilian Sertão, the semi-arid interior, turned to dust. Agricultural systems across 3 continents collapsed within the same 12-month window, not sequentially, not because one failure cascaded into another, simultaneously, because they were all connected to the same atmospheric mechanism. From 1875 to 1878, concurrent multi-year droughts in Asia, Brazil, and Africa, referred to as the Great Drought, caused widespread crop failures, catalyzing the so-called global famine, which had fatalities exceeding 50 million people and long-lasting societal consequences. The monsoon Asia region was the hardest hit, experiencing the single most intense and the second most expansive drought in the last 800 years. 800 years. The research team at the American Meteorological Society wasn't saying this was the worst monsoon failure in recent memory. They were saying it was the worst in 8 centuries of reconstructed climate data. The planet has experienced an enormous number of droughts since the year 1200. None of them matched this one in intensity and spatial extent combined. The strongest El Niño on record from 1877 to 1878 fueled conditions that led to a global famine which killed more than 50 million people across India, China, Brazil, and elsewhere. That was 3 to 4% of the estimated global population at the time, equal to at least 250 million people if it happened today. 250 million people. If the same proportional mortality occurred today. From 1876 to 1878, droughts were followed by famines in Asia, Africa, and South America that in total killed up to 3% of the world population at the time. No deadlier environmental disaster has occurred since, said climatologist Deepti Singh. That statement was made at the American Geophysical Union. No deadlier environmental disaster has occurred since, in a period that includes 2 world wars, the 1918 influenza pandemic, and every subsequent climate event in the observational record. Florence Nightingale, writing from London in 1877, said, "The more one hears about this famine, the more one feels that such a hideous record of human suffering and destruction the world has never seen before." The extreme El Niño may have been primed by cooler waters in the central tropical Pacific from 1870 to 1876. This prolonged period of coolness, the longest on the record, may have led to an immense buildup of warm water in the western tropical Pacific. This ended in a strong La Niña event in 1875 to 76. The La Niña kicked off dry conditions in India, Mexico, and the southwestern U.S., then discharged into a strong El Niño, which brought more dryness across a large fraction of the globe. Extended cool period, subsurface heat buildup preceding La Niña, discharge into record El Niño. Read those 4 steps again. What we just experienced was a 3-year La Niña, not as long as the 1870s precursor, but longer than any La Niña in recent decades. What preceded the 2023 event was an anomalously warm baseline. What is now discharging into the eastern Pacific is a subsurface heat reservoir more than twice the size of what was present at the same stage of the 2023 event. The mechanism is the same, the preconditions rhyme. And the atmosphere this time is operating with a thermal overhead that didn't exist in 1877, human-caused warming adding roughly 1.3 degrees Celsius to the baseline on top of which this event is building. Researchers have written that the 1877 catastrophe was arguably the worst environmental disaster to ever befall humanity, and one of the worst calamities of any sort in at least the last 150 years, with a loss of life comparable to the World Wars and the influenza epidemic of 1918 and 19. I want to be very precise about how to hold all of this. The 1877 event killed 50 million people in a world of roughly 1.3 billion people, with no global food reserve system, no satellite warning infrastructure, no international emergency response capacity, and under colonial governance structures that in many regions deliberately withheld relief. Those conditions do not exist today in the same form. The global food system has buffers that didn't exist in 1877.
But the physical mechanism that caused 1877 doesn't care about our buffers. It operates the same way now that it operated then. And Deepti Singh's assessment that the associated extremes could be more extreme because our atmosphere and oceans are substantially warmer is not speculation. It's physics.
So we have the mechanism, we have the historical case. And now I want to show you something that most of the current coverage is treating as four separate stories. The fire season, the hurricane forecast, the food system, the ocean circulation, when they are actually one story wearing four different faces. The connecting tissue is the Walker circulation disruption. That's the hand on the console of levers. And right now, all four levers are already in motion. Start with the American West because the signal there is the most immediate and the most concrete. Right now, 61% of the lower 48 states is in drought. Washington state has declared statewide drought emergencies for 4 consecutive years, with snowpack at roughly half of normal and melting early. The National Interagency Fire Center and NOAA are tracking high wildfire risk in the southern high plains and southwest through spring, expanding into southern Utah and the Colorado West Slope by June. That's the pre-event baseline, before the Super El Niño has delivered a single season's worth of its full atmospheric influence. 61% of the lower 48 in drought, with snowpack at half of normal and melting ahead of schedule, going into a summer that every major modeling system expects to push temperatures significantly above average across the west and southwest. A strong El Niño can have a major effect on wildfire risk later in the year, says Dr. Theodore Keeping of Imperial College London. The mechanism is layered and worth understanding fully. El Niño winters in the American West and Southwest tend toward wetter conditions. Atmospheric rivers funneled by the shifted jet stream dump rain and snow, which drives rapid vegetation growth. That seems like it should help with fire risk, and in the short term, it does. But by summer, that rapid vegetation growth has cured into fuel. The landscape is carpeted in dried grass, cured brush, desiccated understory, all of it ready for ignition. And the summer heat that follows an El Niño winter in the West tends to be more intense, arriving earlier, persisting longer. El Niño creates a paradox for the western U.S. Wetter winters in some areas, but that moisture grows vegetation that becomes wildfire fuel when summer drought hits. Since the start of 2026, wildfires have burned more than 150 million hectares globally, double what burned in the same period in 2024. Double. And the Super El Niño hasn't peaked yet. The atmospheric signature that supercharges fire weather, the ridge of high pressure, the low relative humidity, the elevated temperatures, the increased wind speeds, builds through the second half of the year as the surface manifestation of the El Niño matures. The Pacific Northwest and British Columbia face what the regional forecasts are calling their most severe fire season in the observational record. The Pacific Northwest faces the highest risk, reduced snowpack, early melt, dry fuels by July. In past El Niño events, the Pacific Northwest averaged 15 to 20% less winter precipitation. And British Columbia, already managing a wildfire crisis that began in 2021 and has not meaningfully resolved in 5 years, enters this fire season with drought-stressed forests sitting on top of a subsurface soil moisture deficit that is now in its third consecutive year. The emergence of a strong El Niño weather pattern in a world warming as a result of human-caused climate change could fuel unprecedented weather extremes. El Niño is expected to supercharge wildfires by increasing the likelihood of severe hot and dry conditions in Australia, the US and Canada, as well as the Amazon rainforest. The Amazon. I want to dwell on that for a moment because the Amazon fire threat is not primarily a North American story. It's a global atmospheric story. The Amazon rainforest generates roughly half of its own rainfall through transpiration. Trees pull water from the soil and release it as vapor, which seeds clouds, which produce rain, which sustains the trees. The technical term for this is a biotic pump. Forest degradation, driven by wildfires, logging, and drought, affects about 40% of the Amazon. 40% of the forest is already in a degraded state. A super El Niño pushes additional heat and drought stress onto a system that's already operating close to a tipping threshold, the point at which the forest can no longer generate enough rainfall to sustain itself, triggering a cascade towards savannification that would permanently alter the atmospheric circulation of the southern hemisphere. That's not a climate model projection for 2050. That's a process that's already begun and that a super El Niño materially accelerates. Now here's the thread that produces the most counterintuitive outcome, the one most people get exactly backwards. El Niño, historically, suppresses Atlantic hurricane activity. The mechanism is wind shear, the difference in wind speed and direction between the lower and upper atmosphere over the tropical Atlantic. El Niño generates elevated wind shear over the Atlantic by pushing the subtropical jet stream equatorward, essentially shredding developing tropical systems before they can organize. Stronger El Niños often produce storm-killing conditions in the Caribbean and tropical Atlantic, resulting in fewer tropical storms and hurricanes there. El Niño increases vertical wind shear over the tropical Atlantic, which tears apart developing hurricanes before they can organize. CSU forecasts just 13 named storms for 2026, below the 14-storm average. During the 2015 to 2016 Super El Niño, only 11 named storms formed. So we're safe from hurricanes this year, right? Fewer storms, less Atlantic activity, the El Niño acting as a natural shield. That's the framing. Here's why it's wrong, or at minimum dangerously incomplete. First, the shear suppression is real, but it's not uniform across the Atlantic basin. Wind shear tends to be strongest over the deep tropics and the Caribbean. It's weaker along the US East Coast and in the Gulf of Mexico. However, El Niño doesn't eliminate risk. Hurricane Andrew formed during the 1991 to 1992 El Niño and caused $27 billion in damage. The 2024 El Niño season produced 4 hurricane landfalls in Florida. Fewer storms don't mean zero storms, and the storms that do develop in a high shear environment tend to be compact, fast-moving systems that don't give forecasters or communities much time to respond. Second, and this is the part most coverage is missing entirely, the Atlantic sea surface temperatures are currently running at levels that partially counteract El Niño's shear suppression. Atlantic sea surface temperatures are at record levels, the same thing that caused 2023 to 2024 to defy the El Niño pattern. The University of Arizona is forecasting 20 named storms, arguing the warm ocean will overpower the shear. CSU says 13. That disagreement is the story of the 2026 season. 20 versus 13. The University of Arizona and CSU, two of the most respected seasonal hurricane forecasting groups in the world, are looking at the same data and arriving at numbers that differ by more than 50%. That's not a rounding error. That's a fundamental scientific disagreement about which physical mechanism dominates. There's a claim circulating on social media that the El Niño means the Atlantic hurricane season is essentially canceled this year. I want to be direct. That is not what the science says. That is not what NOAA says. The disagreement between Arizona and CSU alone tells you that anyone claiming certainty about this season's outcome is not being straight with you. The honest answer is that a super El Niño suppresses storm frequency over the tropical Atlantic. It does not eliminate landfalling hurricane risk. And in a basin running the warmest sea surface temperatures in the observational record, the suppression may be less effective than historical precedent suggests. El Niño subdues the hurricane season in the Atlantic because there is so much heat in the Pacific that outcompetes the Atlantic. Places like the Caribbean will be extra dry this summer and likely have fewer tropical systems. That's meteorologist Jeff Baradelli's assessment. And it represents one legitimate reading of the evidence. But it sits alongside the University of Arizona's 20-storm forecast, and both of those sit alongside the physical fact that the Atlantic Ocean right now is anomalously warm in a way that no Super El Niño forecast model was ever calibrated against. The honest three-interpretation framework here, the most benign reading is that El Niño shear dominates, storm activity stays suppressed, and the Caribbean and Gulf regions get a relatively quiet season. The intermediate reading, where the peer-reviewed literature points, is that El Niño suppresses storm count, but doesn't eliminate major hurricane risk, particularly along the US East Coast and Gulf Coast where shear is lowest. The most concerning reading is that record Atlantic SSTs overpower El Niño shear suppression entirely, producing something like the 2023 to 2024 season, which defied the El Niño suppression pattern and still delivered multiple catastrophic storms. We genuinely don't know which of those three plays out. What we do know is that anyone telling you the hurricane season is canceled because of El Niño has not looked carefully at the Atlantic temperature data. There's a fourth thread. And it's the one that most of the El Niño coverage ignores almost entirely, not because it's speculative, but because it operates on a timescale that doesn't fit comfortably into a weather story. It's called the Atlantic Meridional Overturning Circulation, AMOC. It's the ocean's version of a conveyor belt, a massive system of currents that carries warm surface water northward from the tropics into the North Atlantic, releases that heat into the atmosphere above Scandinavia and the British Isles, then sinks as cold, dense, salty water and returns southward along the ocean floor. It's one of the primary mechanisms by which the planet distributes heat between the tropics and the poles. It's what keeps Western Europe temperate. It's what regulates sea levels along the US East Coast, and it's slowing. The connection to El Niño is not direct, but it's real, and it's important. Here's the mechanism. El Niño increases precipitation over the tropical Americas, atmospheric rivers, flooding rainfall, extended wet seasons across large swaths of South America and the Gulf Coast. That additional freshwater drains into the Atlantic. Freshwater is less dense than saltwater. When it reaches the regions where AMOC needs cold, dense, salty water to sink, the North Atlantic, particularly around Greenland and the Labrador Sea, it sits on the surface and partially blocks the sinking process. A single El Niño event doesn't disrupt AMOC significantly on its own. But a super El Niño delivering anomalously large freshwater input into the Atlantic over an extended period, on top of an AMOC that is already weakening due to Greenland ice melt and long-term ocean warming, is a perturbation that climate scientists are watching carefully. During El Niño, elevated sea surface temperatures enhance air-sea heat fluxes, releasing oceanic heat to the atmosphere. This amplifies tropical atmospheric heating and accelerates global mean surface temperature rise. That thermal amplification reaches the North Atlantic and adds thermal buoyancy to the surface layer. The same buoyancy effect as freshwater, working through a different mechanism toward the same outcome. Reduced density contrast, reduced sinking, reduced AMOC strength. Picture a river that's been partially dammed. The water upstream backs up. It doesn't disappear. Along the US East Coast, that backed up water manifests as elevated sea levels. The Carolinas, Virginia, and the mid-Atlantic coast are already experiencing anomalously high rates of sea level rise, roughly 3 to 4 times the global average in some locations, partly because AMOC's northward current normally pulls water away from the coastline. When that pull weakens, the water piles up. A super El Niño won't collapse AMOC. I want to be precise about that because there's a tendency to conflate what's plausible with what's proven. AMOC weakening over the next decade is well supported by the evidence. Abrupt AMOC collapse within the next few years is a physical possibility, but not a scientific consensus prediction. What a super El Niño may do, through freshwater input, through thermal perturbation, through the interaction of an anomalously warm North Atlantic with anomalously warm overlying air, is accelerate the weakening trend, potentially in a way that's measurable on a timescale of years rather than decades.
That distinction matters, not because AMOC collapse is imminent, but because the event unfolding right now in the Pacific is interacting with an Atlantic system that is already vulnerable. And that interaction is one of the threads of this investigation that I genuinely don't have a clean answer to. What the models suggest, what the evidence supports, and where the honest uncertainty lives.
There's a specific claim circulating right now that I want to address directly. It goes like this. The models failed to predict the 2023 to 2024 El Niño accurately, which means we can't trust what they're saying about the current developing event. And buried inside that claim is an implication that maybe this isn't as serious as the forecasters are saying. That argument deserves an honest, thorough response. Because the people making it aren't wrong about the first part. The 2023 El Niño did develop faster than most models anticipated. The sea surface temperature anomalies in the Niño 3.4 region outpaced model consensus through much of the development phase. Several institutions that had been calling for a moderate event revised sharply upward as the year progressed. The forecasting community genuinely underestimated the speed and strength of that event. So far, that's a fair observation. Here's where it gets misapplied. The argument that model uncertainty means the current signal isn't reliable gets the direction of uncertainty exactly backwards. The models underestimated the 2023 event. They ran too cool, not too warm. If model bias is your concern, the direction of that bias, consistently underestimating El Niño development, strengthens the case for caution, not the case for dismissal. The current subsurface signal is favorable for super El Niño development. The upper ocean heat content anomaly is now above average and the thermocline slope index is below average, both consistent with the early stages of a warm event. And the subsurface heat content data isn't a model output, it's an observation. The IRI's measurement of 6-degree anomalies at 50 to 150 meters depth isn't a projection, It's a reading from the Argo Float Network, from TRITON mooring arrays, from GOTA's reanalysis. The instruments are measuring what's there. The only question is what it does next. There's a second version of this claim, more sophisticated and worth engaging seriously. It goes, El Niño forecasts issued this far in advance have historically poor skill, especially in what scientists call the spring predictability barrier. The atmosphere over the Pacific is particularly chaotic in boreal spring, and small perturbations can push the system toward either amplification or suppression. Historical forecasts, issued in May for a fall-winter El Niño event, have a skill level that's meaningfully above random, but not dramatically so. That's true, and I'll note it plainly because it matters. Still uncertain is whether winds and other weather factors will either ratchet up that ocean heat or temper it, and therefore weaken the possibility of a strong El Niño. That's not a fringe skeptical position. That's Nature magazine this month, describing the genuine, open question that every serious forecaster is wrestling with. But here's what that uncertainty doesn't change. The subsurface heat content is measured, not modeled. More than twice the loading of the 2023 event is an observation. The Kelvin wave propagation is tracked and documented in real time. The SOI response is measured. The atmospheric coupling that's beginning to manifest, the westerly wind bursts, the declining equatorial SOI, those are operational readings that NOAA, the Bureau of Meteorology, and ECMWF are all seeing simultaneously. The atmospheric piece could still disrupt the coupling. A strong burst of easterly trade winds could partially suppress the developing event. Forecasters have watched potential super events fail to materialize before. The spring of 2014 saw enormous optimism about a major event that ultimately underperformed. But 2014 is exactly the cautionary tale a careful person holds in one hand while looking at the 2026 data in the other. Because 2014 had subsurface anomalies that were significant, but they were not more than twice the loading of a previous near-super event. The current signal is. And the atmospheric response, the SOI declining, the trade winds weakening, the early signs of ocean-atmosphere coupling, is arriving earlier in the development cycle than it did in 2014. The honest assessment, model uncertainty is real. Forecast skill in spring is genuinely limited. A careful person doesn't claim certainty about event magnitude at this stage. But the subsurface observations are not in dispute. And the mechanism that connects those observations to global impact, Walker circulation disruption, synchronized breadbasket stress, fire weather amplification, hurricane shear modification, doesn't require a super event to operate. A strong El Niño is already in the most likely category across virtually every forecasting system. The question of whether it becomes super threshold is about magnitude, not mechanism. There's another claim circulating around the current Pacific warming, and it takes a different form. It suggests that what we're seeing isn't natural El Niño development, but evidence of deliberate weather modification. Specifically, marine cloud brightening experiments, or aerosol seeding programs being conducted by governments or research institutions. Let me address this directly, because the people asking deserve an actual answer rather than a dismissal. The impulse behind these claims is not irrational. When events are extreme, when they develop faster than models predicted, when the official framing feels inadequate, people look for explanations. The Pacific is just doing something it's done before, only bigger this time, can feel like an insufficient answer when you're watching the numbers. But here's the specific physics. Marine cloud brightening, the most actively researched form of deliberate weather modification, works by injecting sea salt aerosols into low marine clouds, increasing their reflectivity, and thereby reducing the amount of solar radiation reaching the ocean surface. The mechanism, if it works, cools the ocean. It does not warm it. It cannot produce subsurface heat anomalies. It cannot generate Kelvin waves. It cannot trigger Walker circulation disruption. The direction of the effect is exactly opposite to what we're observing. There are real marine cloud brightening research programs operating, including work conducted by the University of Washington and the Woods Hole Oceanographic Institution. These programs are small-scale, geographically limited, and experimentally designed. Their total energy budget, the amount of solar forcing they could plausibly modify, is measured in fractions of watts per square meter across a localized ocean area. The subsurface heat anomaly currently documented by the IRI represents a thermal energy content that is orders of magnitude larger than anything any current or near-future weather modification program could produce or counteract. The honest steelman of this concern, the place where it has a genuine peer-reviewed scientific substrate, is this. There is real published research on how anthropogenic aerosol emissions, particularly sulfur dioxide from maritime shipping, have historically partially offset ocean warming by brightening marine clouds over major shipping lanes. The International Maritime Organization's 2023 fuel regulations substantially reduced sulfur emissions from global shipping. Some research groups, including work associated with Robert Wood at the University of Washington, have suggested that this aerosol reduction may have contributed to unexpectedly rapid ocean warming in 2023 and 2024 by removing a partial cooling effect. That mechanism is real, it is peer-reviewed, and it structurally resembles the concern underlying the weather modification claim. The idea that human activity affected the ocean's heat budget in a way that official narratives don't fully acknowledge. The difference is this: the shipping aerosol story is an inadvertent effect of a pollution reduction policy, not a deliberate intervention. It doesn't require coordination or concealment, and it's operating through the same physics that climatologists have understood for decades. The conspiracy framing isn't necessary, and it obscures the real human fingerprint, which is that decades of fossil fuel combustion warmed the baseline ocean, and a regulatory change that was good for air quality may have temporarily removed a partial cooling veil that was masking some of that warming. That's the actual human fingerprint on what we're seeing, not deliberate manipulation. Long-term accumulation of thermal energy in the ocean system, on top of which a natural oscillation is now expressing itself at extraordinary amplitude. Most of the conversation about a super El Niño focuses on what the event itself will do: the flooding, the drought, the fire weather, the food price disruption. Less attention goes to what the response system was designed to handle, and the gap between those two things is where this story lives. The atmospheric river warning system covering the western United States, the scale used by NOAA and the National Weather Service to classify and communicate flooding risk, was calibrated against historical atmospheric river events. The scale runs from Category 1, which is beneficial, through Category 5, which is exceptional. The problem is that Category 5 was defined based on the historical record. And the historical record of atmospheric rivers in a world at 1.5 degrees Celsius baseline warming is a shorter, less severe record than what a super El Niño on top of that baseline will deliver. This is not speculation about future climate. This is a gap that hydrologists and water resource engineers have been documenting in published research. The infrastructure, the levees, the flood control channels, the reservoir spillways, the downstream evacuation planning was engineered to perform within parameters derived from historical events. When events exceed those parameters, the engineering assumptions fail. Our heating climate increases the likelihood of extreme precipitation because warmer air holds more moisture and raises the risk of flash flooding. Each degree Celsius of warming adds roughly 7% to the moisture holding capacity of the atmosphere. The atmospheric rivers that a super El Niño delivers into California, the Pacific Northwest, and the interior West will be carrying a moisture burden that is significantly elevated above the events those rivers' flood control infrastructure was designed to manage. The NOAA River Forecast Centers, the Sacramento River Forecast Center, the Northwest River Forecast Center, the Colorado Basin River Forecast Center are extraordinarily capable organizations operating with skilled forecasters who understand the data. But their models are calibrated on the same historical baseline that the infrastructure was designed for. When the event exceeds the calibration range, the uncertainty bounds on their flood forecasts widen dramatically. That's not a criticism of those forecasters. It's a structural limitation of the entire prediction and response system, a system built for a climate that is no longer the climate we're operating in. The same gap exists in the food system. The global grain reserve system, the strategic stockpiles that serve as a buffer against harvest shortfalls, is designed around the assumption of independent breadbasket failures. When one region has a bad year, reserves compensate, but reserves are sized to handle one major shortfall, not three simultaneous ones. Weather extremes have caused multiple breadbasket failures in 1983, 1988, and 2003, when maize, wheat, and soybean production suffered substantial declines in several regions, strongly reducing global supplies. Those events strained the reserve system. They didn't break it. But they occurred in a world with a lower baseline temperature, lower baseline drought stress in key regions, and a food system that had more distributional redundancy. Multiple breadbasket failures heightened food insecurity through two distinct channels: reduced income for poor farmers suffering yield losses, and higher food prices for net buyers. Policymakers must determine whether to prioritize supporting consumers facing price spikes or producers losing their livelihoods. That policy choice, support the farmer or support the consumer, isn't an abstract question. It's the decision that governments from India to Indonesia to Nigeria will be forced to make in real time, with incomplete information, during a synchronized global supply disruption. The history of that decision under pressure, including in 1877, is not encouraging. And here's where the story takes a turn that most coverage is completely missing. Because what I've been describing, the four threads, the synchronized mechanism, the infrastructure gap, assumes we're starting from a neutral baseline. We're not. 2026 is already an extraordinary year for climate change-fueled extreme weather, with the WMO warning that the planet is more out of balance than at any time in observed history. The WMO said that, not a forecasting blog, not a social media alarmist. The World Meteorological Organization, in its official communications, used the phrase more out of balance than at any time in observed history to describe the state of the Earth system before this El Niño has even officially peaked. The drought that already covers 61% of the lower 48 states is not El Niño drought. It's pre-existing drought that El Niño will amplify in some regions and potentially relieve in others. But that enters the El Niño season without the soil moisture buffer that would normally slow the fire weather development and absorb the early season heat. Since the start of 2026, wildfires have burned more than 150 million hectares globally, double what burned in the same period in 2024. That's the pre-El Niño fire baseline, double the 2024 pace in the first months of a year in which the Super El Niño hasn't yet delivered its peak summer fire weather signature. The food system enters this event with inventory levels in several major commodities that are already below 5-year averages. The wheat stocks-to-use ratio, the metric that commodity traders watch as the primary indicator of global supply tightness, is running at levels last seen in the early years of this decade, when the COVID supply chain disruption and the Ukraine conflict combined to produce the food price crisis of 2022. That crisis occurred without a simultaneous multi-breadbasket drought. The current situation begins with comparable stock levels and adds a synchronized El Niño-driven drought mechanism on top. The compound nature of this, the pre-existing drought, the already elevated fire baseline, the compressed food system buffer, the already weakened amok, the already record Atlantic sea surface temperatures, means that a super El Niño isn't arriving into a resilient system with full reserves and plenty of margin. It's arriving into a system that has already been stressed by 4 years of compounding climate extremes.
That's the context the headline framing misses. The question isn't whether a super El Niño would be serious if it arrived in a neutral year. The question is what it does when it arrives in the year it's actually arriving in.
So where does all of this leave us? The subsurface observations are not in dispute. The mechanism is not in dispute. The historical precedent, both 1877 and the modern instrumental record, is not in dispute. What remains genuinely uncertain is magnitude, timing, and the degree to which the atmospheric coupling sustains itself through the development phase. There are 3 honest interpretations of the evidence. I want to present all 3 of them fairly, because they lead to meaningfully different outcomes, and the data doesn't yet tell us with certainty which one is correct. The first interpretation is the most reassuring, and it deserves genuine weight. In this reading, the extraordinary subsurface heat content signal is real but partially offset by a sequence of trade wind reinforcement events through the boreal summer. The atmosphere, rather than amplifying the oceanic signal, partially dampers it, producing a strong El Niño event in the range of 1.55 to 1.8 degrees Niño 3.4 anomaly, comparable to the 2023 to 2024 event. That's a serious event, but not one that exceeds the parameters of recent experience. The impacts: drought in Southeast Asia, flooding in Peru and Ecuador, fire weather amplification in the western U.S., are severe but within the range of what operational response systems have managed before. The food system strains but does not break. The hurricane season is suppressed in the tropics. Global temperatures spike to record levels in 2026 and 2027, then begin to moderate. This interpretation is supported by the genuine uncertainty in atmospheric coupling forecasts at this stage of development. It's supported by the 2014 precedent, an event with a strong subsurface signal that failed to produce a super event. It's supported by the WMO's careful language around probability rather than certainty. This interpretation is not wrong. It accounts for the actual data. A careful person holds it seriously. The second interpretation is where the weight of the current evidence points. The subsurface signal is more than twice the loading of the 2023 event. The atmospheric coupling is arriving earlier in the development cycle. The westerly wind bursts are more sustained than anything comparable at this stage of historical super events. In the western tropical Pacific, temperatures are currently warmer than during the last 2 super events at this time, indicating that the warm supply from the west may not yet be fully released. In this reading, the event crosses super threshold, Niño 3.4 anomaly exceeding 2 degrees Celsius, and peaks in the boreal winter of 2026 to 2027. The compound impacts on the food system, simultaneous breadbasket stress in South Asia, Southern Africa, Brazil, and potentially the US Southern Plains, produce the kind of synchronized supply disruption that the global reserve system was not designed to absorb alone. The Atlantic hurricane season sees fewer storms overall, but several intense events in regions where El Niño shear is weakest. Western U.S. wildfire season is historically severe. Global temperatures in 2027 set records by a margin that would have been unimaginable 5 years ago. This interpretation aligns with what Severe Weather Europe, the IRI, ECMWF, and the majority of dynamical forecast models are currently indicating. The third interpretation is the most concerning one, and I want to present it without sensationalism, just as a physical possibility grounded in the evidence. In this reading, the current subsurface loading exceeds the 2 previous super events, not just at this stage of development, but through the peak, producing a Niño 3.4 anomaly in the range of 2.5 to 3 degrees or above, on a warmer background state than any previous super event has encountered. The Walker circulation doesn't just distort, it partially reverses. The monsoon over South Asia fails for multiple consecutive seasons, as it did in 1877. Brazilian drought persists through the full growing season. Southern African maize yields collapse as they did in 82 to 83, but with no compensating surplus from the Northern Hemisphere because the Northern Hemisphere breadbaskets are simultaneously under drought stress. The food system price shocks exceed anything seen in the 21st century. AMOC weakening accelerates measurably. The Amazon approaches or crosses regional tipping threshold in multiple areas simultaneously. If a big El Niño kicks in, it could bring floods, droughts, and other weather extremes to many parts of the globe, as well as potentially boost 2027's temperatures to record highs. This third interpretation is grounded in physics, not speculation. It doesn't require unusual mechanisms. It requires only that the extraordinary subsurface loading sustains through peak, and that the compounding stressors already in place, the pre-existing drought, the degraded Amazon, the weakened food system buffer, interact with the event's impacts rather than absorbing them. What would distinguish between these 3 interpretations? Primarily, the behavior of the tropical Pacific atmosphere over the next 12 weeks. If a sustained burst of easterly trade winds emerges through June or July, a sequence that would indicate the atmosphere resisting the oceanic signal rather than amplifying it, the first interpretation becomes more likely. If the westerly anomalies persist and strengthen, if the SOI continues declining, if a second major Kelvin wave forms in the Western Pacific, as it did in 1997, the second interpretation moves towards certainty and the third becomes a live possibility. The specific data products to watch: the CPC's weekly ENSO update, published every Thursday; the IRI Quick Look, published monthly; the ECMWF Long-Range Ensemble Forecasts, available through Copernicus Climate Change Service; the TAO TRITON buoy array subsurface data, which is the most direct real-time measurement of the Kelvin wave's current position and intensity. All of those are publicly available. Any working meteorologist watching this video knows exactly where to find them. Let me be precise about what this investigation has established and where the genuine uncertainty lives. What we know. The subsurface heat content anomaly in the central and eastern equatorial Pacific is currently more than twice the value observed at the same stage of the 2023 to 2024 El Niño, which was itself one of the strongest events in the modern record. That measurement is observational, not modeled. The Kelvin wave is documented, propagating eastward, and currently surfacing in the eastern Pacific. Trade winds have weakened, westerly wind bursts have occurred, and the equatorial SOI has turned negative, all consistent with developing ocean-atmosphere coupling. The Niño 3.4 index crossed into positive territory in late March. Zero Carbon Analytics places the probability of El Niño emerging between May and July at 61%, with some models pointing significantly higher. What we don't know: whether the atmospheric coupling sustains long enough and strongly enough to drive the event across superthreshold. Whether the 2014 pattern, strong subsurface signal, failed coupling, underwhelming event repeats. Precisely when and how severely different regional impacts will manifest. Whether record Atlantic sea surface temperatures override El Niño shear suppression in the hurricane context. What we're watching: the weekly ENSO diagnostic discussions from NOAA's Climate Prediction Center in Camp Springs, the TAO TRITON subsurface array for second Kelvin wave formation, the IRI's monthly probabilistic ENSO forecast for ensemble spread changes, the ECMWF extended range ensemble for jet stream configuration changes over North America, the NOAA Coral Reef watch daily 5-kilometer sea surface temperature product for continued warming in the Niño 3.4 region, and the CPC's seasonal drought outlook, updated monthly, for evolving soil moisture conditions across western U.S. breadbasket regions. I'm going to say something plainly. The evidence does not guarantee a catastrophic outcome. The honest reading of the uncertainty means a capable person can hold the first interpretation, strong but manageable event, as a genuine possibility. The spring predictability barrier is real. The atmosphere has resisted strong subsurface signals before, but the evidence also doesn't allow comfortable reassurance. More than twice the subsurface loading of an event that already broke the 1.5-degree barrier, a global food system under pre-existing stress, a western U.S. fire landscape already burning at double the 2024 pace before the El Niño summer arrives, an Atlantic that's running temperature records that confound every hurricane suppression forecast, a monsoon system serving 3 billion people that is already being pushed by a Walker circulation that is already beginning to distort. The uncertainty is about timing and magnitude. The mechanism is not uncertain. The title of this investigation is accurate in a way that the current headlines aren't fully capturing. Most of the coverage is framing this as a developing event, something that might happen, something we're watching, something that will become clearer in the coming months. And that's technically correct. The peak of the El Niño, if it crosses super threshold, is probably still 6 to 9 months away. The full impact signature on global agriculture won't be clear until the Northern Hemisphere harvest seasons of 2027, but several of the mechanisms have already been set in motion. They can't be undone by a June trade wind burst. They can't be reversed by a revised CPC outlook. The Kelvin wave has already surfaced in the Eastern Pacific. The thermal energy it's delivering to the surface layer of the ocean is already modifying sea surface temperatures. The Walker circulation is already beginning to distort. The atmospheric rivers that will flood parts of western South America through the remainder of 2026 are being shaped by ocean conditions that already exist. The drought that is expanding across Southeast Asia is already being driven by moisture patterns that reflect the early stages of this event. Recent research shows that El Niño events do not just cause short-term disruption, but can slow improvements in mortality for years, reducing life expectancy and generating substantial long-term economic losses in high-income Pacific Rim countries, including the US, Canada, Australia, Chile, Japan, and South Korea. Not just the event duration. Years afterward, the economic and mortality effects of a strong El Niño don't stop when the Niño 3.4 index returns to neutral. They propagate through agricultural supply chains, through food price inflation, through the downstream consequences of wildfire seasons that leave watersheds destabilized and municipalities without reliable water supplies. The excess heat brought to the surface by El Niño, combined with the planet's warming due to climate change, will lead to record-breaking global warmth. Record global temperatures are expected later this year, next year, or both. That's Daniel Swain at UCLA, one of the most careful and precise climate scientists working in the space of extreme event attribution. Later this year, next year, or both. Not maybe. Expected. And here's the thing that the "it's not over" framing of this investigation's title is actually pointing toward. The physics of ENSO means that what comes after a super El Niño is eventually a La Niña. The ocean, having discharged its heat eastward, eventually reloads. The cold upwelling returns to the eastern Pacific. The weather whiplash reverses direction. Drought where there was flood, flood where there was drought. For the global food system, that whiplash is in some ways as dangerous as the El Niño itself. Agricultural systems that adapted to El Niño drought conditions, fallowed fields, planted drought-resistant varieties, drawn down reserves, face a different set of stressors when the La Niña arrives. The back-to-back sequence of a super event followed by a La Niña has historically produced some of the most severe food security crises in the observational record. The 1877 event didn't end when the El Niño did. The drought persisted through the La Niña that followed because the soil moisture deficit was so severe that the return of normal rainfall patterns couldn't restore agricultural conditions within a single season. The famine ran for 2 years after the El Niño peak. That's not a prediction for what happens in 2027. It's a physical constraint. Recovery from the agricultural disruption that a super El Niño delivers doesn't happen at El Niño speed. It happens at the speed of soil moisture recharge, of seed stock recovery, of replanting cycles, of food price inflation working its way through global supply chains. Here's what I can tell you with confidence at the end of this investigation. The subsurface signal in the Pacific right now is the largest ever documented at this stage of an El Niño development cycle. The mechanism connecting that signal to global impacts, the Walker circulation, the monsoon system, the fire weather pattern, the food system stress, the hurricane shear modification, is well understood, well documented, and operating right now. The uncertainty is in magnitude and timing, not in mechanism. The historical parallel to 1877 is not alarmism. It's the closest analog in the instrumental record, identified independently by multiple research groups, including Deepti Singh's team at Washington State, whose published work in the Journal of Climate established that the Monsoon Asia drought of 1877 was the most intense and second most extensive in 800 years of reconstructed climate data. The mechanism that produced that event, extended La Niña precondition, massive subsurface heat buildup, rapid discharge into record El Niño, simultaneous multi-breadbasket failure, rhymes structurally with what's assembling right now. What's different today is not the physics. What's different is the background thermal state, 1.3 degrees Celsius of human-caused warming that didn't exist in 1877. That doesn't make the outcome worse automatically, but it means the energy available for every mechanism El Niño deploys is elevated above anything the observational record was calibrated against. Deepti Singh said, "What is different now is that our atmosphere and oceans are substantially warmer than they were in the 1870s, which means the associated extremes could be more extreme. Could be more extreme. Not will be, could be. That's the honest framing. And a careful person takes that framing seriously, not because they're prone to alarm, but because the cost of being wrong in the direction of dismissal, in 1877, that cost was 50 million lives, is categorically different from the cost of being wrong in the direction of caution."
We're going to keep watching. The CPC's Thursday ENSO updates, the IRI monthly quick look, the ECMWF ensemble, the TAO/TRITON buoy array, the NOAA Coral Reef Watch SST product. When this story moves, when the atmospheric coupling clarifies in one direction or the other, when the summer trade wind season tells us which interpretation is correct, we'll be here with the data. And when the whiplash comes, when the La Niña follows, as it always does, and the second half of the story begins, that investigation is already waiting.